Welcome to the benchmarking video for understanding the customer and the market and defining design needs and wants. This is Jim Heisey, Senior Lecturer in Mechanical Engineering. Today, what you're going to learn here is a process of documenting customer needs and wants so that design requirements can be developed, and how the customer requirement sheet works with a QFD to link the design to the voice of the customer. Some key terms that you will get out of this is benchmark, metric, engineering spec or specification, voice of the customer, and understanding shall versus should, otherwise as we refer to it as a need versus a want. If we take a look at the DMADVR toolbox that we've been working with in class, we have all of these particular tools that are a part of that toolbox, items that we can use for developing our design and making sure that we are well connected with the customer. The two key tools that we'll be talking about in the next two lectures are the customer requirements, which we'll be using for benchmarking of competitive designs and doing a market assessment, and the engineering specifications sheet, which we'll use to help us to turn those customer requirements into design requirements. To get started with benchmarking, first thing we want to do is we want to look at the market. We need to do some market research. We have to ask ourselves, who are the customers? Do we understand what these customers have for needs and wants? What are the importance of these benefits to the customers once we have the needs and wants identified? And how well does the competition meet these needs and wants? Let me define first, though, what is the difference between a need and a want? A need is something that absolutely has to be there. If it is not provided through the product or the service, then the customer's essentials go unresolved. A want is something that would make the customer happy, but is not necessary to them being serviced by whatever it is that you're trying to create. So a need is something that must be provided in the design. A want is something that can be provided and will raise the happiness or desire of the customer to your product. Key in doing the research and analysis is we want to do what's called benchmarking. We want to define the metrics that will measure the performance of the product or service, and all this information that we collect can be inserted in the QFD section so that we can create a map for ourselves to show directly how well we are meeting the needs and wants of the customer. So in doing benchmarking using the QFD, we first want to define who the customers are and the requirements. And the first and very critical step in doing this all is the project charter. By now you have completed a project charter on your project, so you know roughly who your customers are. You also probably at this point have identified some key metrics that may have been stated by the customer that have to be there. From here now, though, we have to define the level of performance that is necessary for success. We're going to do this by doing market analysis. We're going to ask ourselves, what are the current user choices? What are the current consumer choices that they have? And then we want to take a look at what are the functions or features that are present in the products or processes that they are choosing that meet the needs and wants of the customer. This is where the benchmarking occurs. Lastly, we may wind up doing some trade studies just to take a look at, once we've identified all of these choices and their functions and features, to be taking a look at what compromises were made in the various designs in order to meet the desired state for pleasing the customer. Lastly, we want to take a look at functionalities and features and understand what are present. The ideal state is to have all the requirements for the customer met with a minimum number of functions and features. The reason for this is very straightforward. Less parts usually equals less cost, which also usually equals higher reliability. If we take a look at the house of quality in its typical format, what we're attempting to do here is we're attempting to identify the customers and what their needs and wants are. Then we're going to rank those in importance. As we have those identified, then we'll take a look at the customer requirements and understand what product features or functions may be present there. After we've done this, we'll take a look at the market and we'll understand what's available there and how that goes about meeting the needs and wants of the customers. We'll also be able, in doing this analysis of the market, determine what some of the performance metrics or measures are going to be, and we can insert that into the QFD. By doing this, we now have everything mapped out fully as to what the market is, how it meets the customer's needs and wants, and what has to be present in a product in order to fulfill that mission. If we take a look at the QFD that is in the DMADVR toolbox, all the same features are there. We have the customers, customer requirements, and the rankings for such. We also have the function and features section, and an area to put in the market, who's competing, and how well do they do. And then also a section for us to put the measures in as we're able to determine those through our benchmarking. So some advice about benchmarking. First, in looking at the customers, you want to identify everyone who is impacted by your efforts and also prioritize who those people are as far as their impact to you and your importance. Who rises to the top? Now, in doing benchmarking, don't be afraid to use your intuition. After the first pass at ranking, if the numbers don't seem right, ask yourself, did we miss any important objectives? Often we call those C2Qs. C2Q is an acronym that stands for critical to quality. And of course, quality is understanding the measure of performance of a product. Also, did we miss any important criteria? That is, features or functions that should be present in the product. And then lastly, is there a way we can combine needs to create an even better result? This is the opportunity to innovate, to create new features that did not exist before. After doing this, you can reevaluate your assumptions and your data. So if you reevaluate your assumptions, does this impact the rankings that you've had? If you go in and reevaluate data, is there other information or analysis sources available that could lead to a better assessment? Some points to consider. As you're looking at the various products and ranking them, what were the major drawbacks or challenges of the products that weren't popular with the customer? Also, of those that were popular with the customer, what were their major strengths? Also, does the information gathered fully define the market and the situation that you intend to work in? Kano analysis can be very helpful in defining these situations further if you have any questions. Key thing here is know your customer. Know not only who your customers are, but also know what choices do they make and how do they make them. Two available slideshows that will help you in understanding this better. Material from EWB, which looks at microeconomy kits and evaluating markets in developing economies, and material from industrial design, which takes a look a little closer at who the customer is, what makes them happy, and how you might go about assessing ways to make them happy. Both of these lectures will be posted on your course site. Let's take a look at an example here. We'll start with a simple cook stove. This is a microeconomy kit project that would be done for something like Engineers Without Borders. Our target market area is a Rwanda village where the customers there typically cook on 3-stone fires. This sort of method is very inefficient. It uses more wood and it takes more time typically to cook. It is also unsafe. Exposure to smoke and open flame creates risks for burns and blindness and other smoke inhalation hazards. 3-stone fire is also unstable. It may not hold the pot well. But as we look at these customers, we also understand that their average income per day is very low at $1 a day, and that much of the villagers' income is spent on food and fuel, leaving little money left over for other needs and wants. So creating a stove that could be more efficient would be very desirable for them, but it has to be affordable. Typical meals are cooked in 1 or 2 pots. If we're looking at multiple pots, then our stove either has to be capable of holding more than 1 pot, or we want to make the stove affordable enough that it can afford to buy more than one. If we take a look at 2 major customers in this project, we have the end user of the stove and the entrepreneur who's going to build the stove using the microeconomy kit that we have and selling it. So if we take a look at the needs and wants of the end user, first and foremost, because of their income level, affordable cost is there. Also, because they have so little money, it has to be efficient in using less wood or fuel to cook. And it should create enough heat so it can boil water quickly and cook food quickly, but without burning. Desires would be, must be easy to light, must be easy to use. Allows the original cookware to be used so that the customer or end user doesn't have to go out and buy new utensils. And should be easy to control the flame size and should have less smoke. The outside of the stove also should not be hot so that reduces the risk of burns when touched. And it should be portable so it can be moved around, and if possible have handles to make it easy to carry. For the entrepreneur, they obviously want to make this easily, so they'd like to use least amount of materials or minimum number of materials, and like to source those materials locally. Also, they'd like the construction to be simple. In order to get it to the market, they desire to have it to be lightweight and easy to transport, easy to repair, no special tools required to build or assemble, also be low cost to build. Also, to help it make it be easy to sell, they'd like it to be unique and have a pleasant appearance. And lastly, to be stable and to have a position or features for holding a pot. Note that these are the two main customers, but there easily could be other stakeholders in the project. So let's take a look at an example toolbox that we have here that was developed by a team that was called Meyer Tech. Meyer Tech identified 4 major stoves that they could evaluate as being competitors in their market. We see these 4 stoves listed here. The Weber grill was added just to get a relative comparison between the typical things that are used in the United States, but the analysis could be done without that. So we see here the Chitetezo Mabala, the Green Fire Stove, and the Rocket Stove. All 3 of these stoves are known for their efficiency, their reasonable costs, and their portability. If we take a look at now the rankings here as they would go into a customer requirements worksheet, we can see we have our 2 main customers listed here and their needs and wants. What we can do is on the left is go down and rank each of these needs and wants in importance to each particular customer. And then we can take a look at the characteristics of each of the 4 competitive products here and list them down as to their ability to fulfill those needs and wants. We can take that information then and put it into our customer requirements worksheet. We can take the information from our project charter, insert that here so we have the opportunity defined. We can take the information we had as to what is the market and list that into here. From there, we can take the customers and their rankings of importance, put them into this worksheet here, and then lastly, define our competitive products and put their rankings there. This information then can be transferred easily into the QFD. So here we have again the worksheet showing the customer requirements, their rankings, and the competitive products. If we take a look at the customer and customer requirements section in the QFD, we can see very clearly we can put our customer requirements in here by taking the list that is available with the customers on the customer requirements sheet and compiling them. If we take a look at low cost, we can see that exists in both customers, so we can put that there. We also have efficiency, less wood, cooks food quickly without burning, easy to control flame size. We have safety concerns, both with the end user and with the entrepreneur. We also have portability and user friendliness, and lastly, ease of assembly. These rankings then can be put into the QFD by compiling those as well. And if you take time to pause the video at this point, you can make the comparison between the customer requirements and the rankings in the QFD and see how those numbers were generated. Moving on, also, we take a look at the products and features section of the QFD. Some of the functions and features will jump out at us in the customer requirements. In the case of the entrepreneur, it says it needs minimal materials, local materials, and simple construction. These can be easily tracked and can go directly into the product features or functions area. Likewise, if we take a look at lightweight, easy to transport, that is listed, and also low cost to build. Very direct, easily defined measure. They can be put in there, and those can be listed in our product features and functions and become design requirements. If we take a look at the market section as well on the QFD, again, we've got the customer requirements listed there. But we also have the competitors, and then we have the rankings, and those can be compiled as well and listed here. Again, you can pause the video at this point to take a look at the rankings and how they were combined into this market assessment. By doing so, we now can have a direct comparison between the different products and understand who is the strongest in the market in meeting the needs and wants of the customer. Let's take a look at a second example. Sometimes not everything that you're doing may be a direct market. Maybe you're designing something for a competition. In this case, this sheet still works well, but our tactic is a little different. In this case, the customer requirements and the benchmark will be done by understanding, first of all, what is our opportunity. In this case, we're taking a look at a design competition for NASA robotic regolith mining. And the key questions we have here to ask ourselves is, we're going to design, build, and test and operate a Moon or Mars capable robotic excavation system for collecting material called regolith. That design is going to compete at a competition at NASA, and ideally the design must meet all the requirements as described in the points table and be as good or better than the competitors so that we can guarantee our success at the competition. So the first thing to do would be to take a look at the competition points table. Here we have listed all of the points that can be generated in the competition for the NASA. You can see the various different categories as they exist. What we want to do is review this points category and determine what systems must be present in order to complete the desired mission. Here's a key thing. Think action. Look for action terms that may be in the rules. In this case, we can see it has mined. Well, mine would imply that our rover would have to dig up material, hold it, and deposit it. Also, we can see other action terms: efficiency, mass, energy consumption, enclosures or protection, sealing, active dust control, dust-free operation, and autonomous operations. All these will define systems that have to be present in the design of the rover. So some key questions to ask ourselves when doing the benchmarking. What metrics here best exemplify success for NASA? What functions must be present to achieve the system requirements? What costs or risks are associated with the function features that we choose? And what are the other systems in technology or nature that we can exploit to make our system most successful? Now let's take a look at the competition. These are designs that have demonstrated capability at previous competitions. These are all past champions. We've identified 4 of the best here: West Virginia University, Laurentian University, University of Alabama, and Iowa State University. We've also noted some things here as to what year they won and some characteristics that made these designs winners. First and foremost, the amount of material they mined. Second of all, because weight is a critical issue with going into space and you're penalized for weight, we've noted the weights of each of these rovers. So now that information can be put into our customer requirements sheet, again, following the same track of defining, in this case, the market is the competition, so we're listing the various competitors. And in the end, we have the specific points, and we made note of the performance of each of these teams and made an assessment as to what sort of points they earned. This information could be gathered from the competition source. In this case, NASA provided this data back so we could make a direct assessment. But some of this information could also be determined by doing what's called reverse engineering, doing analysis of the systems and understanding how they might perform based on the characteristics that are visible to the engineer. If we take a look here in this list, we can see some key numbers that jump out at us that define success at the competition. such as the amount of regolith collected, the weight of the rover, how it's scored on dust reduction, and how it fared on autonomous operation. Lastly, we can take a look at the points garnered and understand what points level our system has to be capable of attaining in order to be competitive. So here we take a look at the customer requirements worksheet again. We can see the 4 different products that we are evaluating, or in this case designs evaluating in the competition. We've listed here in the customer requirements section each of the rules or the points areas and their importance to the winning of the competition. We've also listed the 4 competitors. In addition to this, in the information section, we go in each of the areas, try to best describe how the designs, each of the designs, fulfill each of the points categories, getting as much data or information in there as we can. Through this assessment, we can see metrics that start to jump out at us that would define what our final design has to have in order to be competitive. So with that benchmarking, the DMADVR toolbox, the customer requirements and engineering specification sheets help us to collect the customer requirements and will aid in developing our engineering specifications. Putting this information in the QFD will allow us to have a quick visual connection between the customer and our design, thereby assuring the success of our design. And finally, functional decomposition can be used to help identify functions and features for system characteristics that will fulfill the customer needs and wants. Next, we will be taking a look at creating engineering specifications from our customer requirements. Thank you for watching this video.